This is 1. This is 2. 3. But what is a number? If I asked you to define what a number actually is, you'd probably say something like a way to count things or a quantity. And you wouldn't be wrong, but you also wouldn't be right. See, the thing about mathematics is that what seems obvious on the surface usually hides something profound underneath. And numbers? Numbers are far stranger than you think. Welcome to Math from Zero. I'm going to teach you mathematics the way it should be taught, by building it from the ground up, piece by piece, until the seemingly impossible becomes inevitable. Let me start with a question that sounds simple but isn't. Is the number 3 a discovery or an invention? Think about it. Did humans discover the number 3 like we discovered fire? Or did we invent it, like we invented the wheel? Here's what's wild. Mathematicians aren't sure either, and this isn't just philosophical navel-gazing. The answer to this question shapes how we understand reality itself. Because if numbers are discoveries, then mathematics exists independently of humans. It's written into the fabric of the universe. But if they're inventions, then math is just a really useful fiction we tell ourselves. So, which is it? To answer that, we need to go back to the beginning. Before algebra, before calculus, before even basic arithmetic, we need to ask, what came first? The earliest mathematical evidence we have isn't numbers as we know them. It's marks. Scratches on bones from 40,000 years ago. Someone, some human being was tracking something, keeping count. But here's the fascinating part. They weren't counting numbers, they were matching. 1 mammoth, 1 mark. 2 mammoths, 2 marks. They were creating what mathematicians call a one-to-one correspondence. And this is where mathematics actually begins. Not with numbers, but with patterns, with relationships, with the recognition that this pile of rocks has the same something as that group of animals. That something is what we now call quantity. But quantity isn't a thing you can touch or see. It's an abstraction. It's a pattern that exists in your mind. Now, here's where it gets really interesting. Once early humans could recognize this abstract sameness, they made one of the most revolutionary leaps in human history. They realized they could think about the threeness of 3 sheep without thinking about the sheep at all. This is abstraction at its most pure. They took a property of objects and made it an object itself. They turned an adjective into a noun. And with that leap, mathematics was born. Because now they could manipulate these abstract objects, these numbers, according to rules. They could predict. They could calculate. They could explore what would happen if. But here's what's remarkable. When they did this, when they started playing with these abstract objects, they kept discovering that their manipulations corresponded to things in the real world. And that brings us back to our question, discovery or invention? Because if numbers are just human inventions, why do they work so well to describe reality? Why does abstract mathematical reasoning lead us to discover new physical laws? Einstein called this the unreasonable effectiveness of mathematics. The fact that math works at all is suspicious. But here's what I think is happening. And this is going to be the foundation for everything we build in this series. I think numbers are both discoveries and inventions. We invented the symbols, the notation, the specific ways we talk about them. But the patterns they represent, the relationships they capture, those we discovered. Because patterns exist everywhere, in the structure of crystals, in the orbits of planets, in the way populations grow and markets crash. Mathematics isn't separate from reality. It is reality, seen through the lens of pattern and relationship. And that's what we're going to explore together. We're going to build mathematics from the ground up, starting with the most basic patterns and working our way to the most sophisticated ideas in human knowledge. We'll start with counting and end with calculus. We'll begin with addition and arrive at quantum mechanics. We'll take the path that humanity took, but faster and with better visuals. But when you build mathematics piece by piece, when you see how each idea grows naturally from the one before it, something magical happens. The impossible becomes inevitable. So that's what we're doing here. We're building mathematics like code, one logical step at a time, with nothing taken for granted and everything explained. Next time, we'll start building. We'll take our understanding of quantity and turn it into something more powerful, the concept of zero. And yes, zero is far weirder than you think. This is Math from Zero. Let's build something beautiful.